Hello class, welcome to day 2 of calculus. We're going to work more with limits, except we're not going to be looking at graphs as much. We're going to use a substitution method. So, the whole idea of substitution method is we plug in a number for x, whatever number they give us. So for this very first example, I'm going to use x equals 1. And when I plug it in, I get 1 squared plus 5 times 1 plus 6 over 1 squared minus 4. I get 12 over negative 3, which is negative 4. And I like that. Negative 4 is a number. The next example, I'm going to use x equals negative 3. And I'm going to plug that in. I get negative 3 parentheses squared plus 5, negative 3 parentheses plus 6 over negative 3 parentheses squared minus 4. Should always put parentheses around negative numbers because when you square it, you get the right results. I get 0 over 5, and $0 divided into 5 pieces is 0. 0 is a number. I like it. So I get a result of 0. Moving down to this one, I'm going to use x equals 2, and I get, oops, what the heck was that? Equals 2 squared plus 5 times 2 plus 6 over 2 times squared minus 4. I get 20 over 0. And you should know a number divided by 0 is undefined. But where do I go from there? So I'm asking, is there any problem with any of these? And the answer is yes. Number 3, a number divided by 0 is undefined. But for limits, whenever we do limits, we put down D and E, does not exist. So I know that this one says undefined, but I don't put undefined for limits. That is not proper notation. You got to put down D and E. Values are undefined. Limits are do not exist. So for this next one, I'm going to use x equals negative 2. And I get negative 2 squared plus 5 times negative 2 plus 6 over negative 2 squared minus 4. And I get this 0 divided by 0 business. Those who had me last year, you realize that I do not like this at all. I'm very unhappy. I make a sad face. Is there a problem? Yeah, there's a problem. 0 divided by 0 is indeterminate. Use your smartphone and ask Siri, what's 0 divided by 0? And she'll tell you indeterminate, or she may tell you a sad little story about Cookie Monster. Here's the problem. This tells you nothing. That's one reason why you're sad. And here's another reason. You got to do more work. This is the other reason why you're sad. 0 over 0 tells you nothing, and you have to do more work to figure out the limit. So that's what we're going to work on the next page. So 0 out of 0 is a very sad thing to get. We need to do more work, maybe by factoring. So if I factor this, I get x plus 3, x plus 2, and I get x minus 2, x plus 2. You need to work on your factoring. Your factoring has to be perfect. I notice that some things cancel out. I got that slash that went through the middle here, but you're going to have to deal with it. What's left over? X plus 3, x minus 2. Now I can use x equals negative 2. I get negative 2 plus 3 over negative 2 minus 2. I get 1 over negative 4, or negative 1/4. So this limit is equal to negative 1/4. 0 over 0, you cannot leave it as that. So when we do limits by substitution, all we're doing is plugging in a number for x and seeing what we get. We have options. We can get a number over number, 5 over 3, 12 over 4, whatever. You have lots of options. 0 divided by a number is fine because 0 on top is good. That's just 0. But when we have a number divided by 0, that is not great. But for limits, it's okay. It just means the limit does not exist. But our worst case scenario is this whole 0 over 0 business. I get my sad face. I have to do more work, usually factoring. So for the next page and a half, we're going to do some examples. I'm probably going to pause the video to write out all the work myself. I'm not going to keep the video live by doing all that. It's just simple algebra work. But we'll talk about when we get 0 divided by 0 on the next page. I'll probably pause the video for that. So why don't you try these on your own and see how you do and check your results. Okay, you see I did these 4 examples on the bottom of page 2. They were pretty easy to plug in the numbers. I got nice results, nothing weird going on. You know, 0 is an answer sometimes. It's not that big of a deal. Okay, I'm going to go on to the next page. Okay, the same thing with these next 4 problems. Nothing really fancy here, just plugging in the value for x that is given to us and simplifying using our algebra skills. And, you know, again, 0 is okay as a result. Okay, the next few problems. Okay, you can see for every one of these problems, we're getting 0 over 0 when we plug in that number for x. So I have to do more work. On number 9, 10, and 11, we did some factoring. Things canceled out. That means they're gone, and you're left over with, like a number 9, x plus 1. But then I have to go back and plug in whatever number I was told. So number 9, I had to plug in 1. And number 10, when I had x minus 2, I had to plug in the negative 2. When you get it down to x plus 1 or x minus 2, you're not solving for x. Remember, limits are solving for y. These are all y values. So once you get it down to a simplified form, you're going back in and plugging in whatever value of x was given to you. Number 12 is a little bit different. I got 0 over 0, but I'm not factoring. I'm actually expanding it. So I expanded x minus 2 to x squared minus 4x plus 4. I did the derivative property and got 6x minus 12 plus 8. And on all the numbers on top canceled, and you're left over with x squared plus 2x over x, and x cancels out. You're left over with an x plus 2, but then you had to go back and plug in 0. That's why I got a final result of 2. Now the next 2 problems. Number 14 is a little bit harder than all the rest. Okay, number 13 is kind of like number 9, 10, and 11, where you get 0 over 0, you factor it, things cancel out, you plug back in negative 5, you get negative 7. Not too hard. 14 is more difficult because this is called a complex fraction. You have a fraction in the numerator over a denominator, and you plug in 0, and you get 0 over 0. So instead of factoring, we do something where I say multiply by 1. And multiply by 1, that 1 could be anything. 5 over 5 is 1. But whenever you multiply by 1, you don't change the value of anything, you kind of change the way it looks like. So when I do this problem and I multiply by 1, and you see I've done that here, that this fraction here is 1, I've actually just chosen these denominators as what I chose. That's how I got the 4 parentheses x minus 4. It's just those two denominators right there. And then I distribute. So when I do 1 over x minus 4 times 4x minus 4, the x minus 4 cancels out. I get 4. I do the same thing for the second fraction here. I get x minus 4 left over. And then I multiply this whole denominator. I don't multiply it out. I just leave it as 4 times x minus 4. What happens, I get something very nice, that these 4's in the numerator cancel, and I get x over that whole fraction. The x's cancel out. You left the 1 on top. And remember, we are plugging in x equals 0. And I do all that work, and I get negative 1/16. This is a weird one. It's a lot harder than the others. The next topic I'm looking at is restricted domain. Some functions have all real numbers for the domain, like a line or a quadratic or an exponential, but not all of them. We saw a couple that didn't. That was 1 over x and the square root of x. So there are restrictions. I cannot use all real numbers. So I'm going to call rule number 1 the one that has the denominator, and rule number 2 is the one that has a square root. So rule number 1 is that you cannot use a number for x that gives you 0 in the denominator. And rule number 2 is that I can't take square roots of negative numbers. Not really. So let's look at what our restrictions are. 1 over x and the square root of x. So for this first function, 1 over x, my restriction is that the denominator cannot equal 0. So in this case, x cannot equal 0. So I need to remove it from the domain. So my domain would be all real numbers, except I'm going to skip over 0. All real numbers except 0. Okay? Negative infinity to 0, parentheses, 0 to infinity. This next function, the square root of x, my restriction is I cannot take the square root of a negative number. I can take the square root of 0. I cannot take the square root of negative 4. So x must be greater than or equal to 0. I can do 0. So it has to be non-negative. My domain for this one will be including 0 to infinity. So let's apply it to more difficult situations. The next two on this page aren't really more difficult. We're just looking at, again, my denominator cannot equal 0. So x minus 2 cannot equal 0. So x cannot equal 2. So I have all real numbers except I skip over the number 2. And then for this one, this part has to be non-negative. So x minus 2 has to be greater than or equal to 0. X has to be greater than 2. Or including 2 to infinity. Those are my domain for that one. On the next page, we're going to do a bunch of problems, and we're going to talk about what rules apply to which one. So I'm going to go through the examples and first talk about the rules. So in problem number 1, I see a denominator, so I know I'm going to use rule number 1. On problem number 2, I see a square root. That means I'm going to use rule number 2. On number 3, I see a denominator and a square root, so I'm going to do the square root part first, and then I'm going to apply rule number 1 to that because I see a denominator. And then for number 4, I see this top part is a rule number 2, but I see a denominator, so I'm going to have to do a rule number 1 here. And we're going to get to all these parts. So I'm going to change to blue. This part, 2x minus 5 cannot equal 0. X cannot equal 5 over 2. Negative infinity to 5 over 2, union 5 over 2 to infinity. See a square root. This part here cannot be negative. Solve for x. I get my domain is 2 to infinity. Now the one with rule 2 and rule 1. Well, the rule 2 is going to be this part is going to be 5x minus 2 is greater than or equal to 0. But because there's a rule 1 with it, I'm going to get rid of that part. Since it's in the denominator, I can't have it equal 0, so I had to get rid of that equal 0 part. I solve for x. I get greater than 2/5, parentheses 2/5 to infinity, where problem number 2 was bracket 2 to infinity. Now this one's going to have a couple parts to it. Rule number 2 is going to be 2x plus 3 is greater than or equal 0. X is greater than or equal to negative 3 over 2. So right now, my domain is negative 3 over 2 to infinity. But rule number 1 says x plus 4 cannot equal 0, or x cannot equal negative 4. And I look at this and I realize that this is not in the domain of what I had before. So I'm going to ignore it. So even though I can't use negative 4 was part of this domain anyways. So my final result is still just negative 3 over 2 to infinity. That did not change. So the denominator rule, or rule number 1, had no effect on what we did. Okay, so number 5 is rule number 2 and rule number 1, just like number 4. I set them both up. I realize right now I have a restricted domain from rule number 2 of including negative 2/3 to infinity. Rule number 1 is I can't use 1, and that's in the domain. So now I have to remove that from this. So I have to do negative 2/3 to 1, parentheses union 1 to infinity. That's all real number is greater than negative 2/3, but getting rid of 1 because that was part of the domain. And number 6, the top has no restriction. It is fine. I can have anything on the numerator, but the bottom has that square root in the denominator, so I just use the greater than sign, and I get parentheses negative 3 over 2 to infinity. So these last set of problems are going to talk about composition, and we're going to spend a more thorough day on composition, but this is something you should remember from Algebra 2. Composition is when you put a function in a function. So for this example, it would be first g and then into f. So it would be f of g, which is the square root of 3x minus 1. And that becomes, well, that goes in the denominator, becomes 1 over the square root of 3x minus 1. And that is the new composition function. But now I have to do the domain. And, well, again, this is rule 2 with rule 1, 3x minus 1 just greater than 0, or x greater than 1/3, 1/3 to infinity. And this next problem is going to be first h and then into g. So it's g and h is just x plus 2. And that is going to equal, well, the square root of 3 times x plus 2 when I put h in there, minus 1, and I get the square root of 3x plus 6 minus 1 is plus 5. Well, this is just rule number 2. Nothing special. Rule 2, 3x plus 5 is greater than or equal to 0. X is greater than or equal to negative 5/3. So my domain is negative 5/3 to infinity, and I made a mistake, which is fine. I can erase it because it should be bracket. It is included. Okay, thank you for watching this video. Come hit me on Zoom if you have any questions.